Hello friends, in the previous video we discussed about the flow through pipes in which we discussed about the different losses that are occurring when the fluid is flowing through the pipes, mainly the major losses and the minor losses, and also the two important equations used to determine these losses. One is Darcy's equation, second one is Chazy's equation. In this video, we'll take some problems which is based on these two equations, and you can expect this question in the examination from 8 to 10 marks. The first problem, I will read out the problem. A pipe of 300-meter long with a diameter of 0.3 meter is supplying water. Calculate the discharge of water through the pipe. The loss of head due to friction is 1.5 meter. Take Darcy's coefficient as 0.01. In this problem, the given data is the length of the pipe L is equal to 300 meter, the diameter of the pipe D is equal to 0.3 meter, and the loss of head due to friction, that is HF, is equal to 1.5 meter, and the Darcy's coefficient F is equal to 0.01. We want to find the discharge. We know that the loss of head due to friction HF is given by FL Q square divided by 3 into D raised to 5. Rearranging the terms, we get Q square is equal to 3HF D raised to 5 divided by F into L. Therefore, Q is equal to under root of 3HF D raised to 5 divided by F into L. From the given data, 3HF is 1.5 into D 0.3 raised to 5 divided by F 0.01 and L 300. If you calculate this, you will be getting Q is equal to 0.060 meter cube per second. This is what he has asked. But usually discharge is expressed in LPS, that is liters per second. And you know how to convert the meter cube into liter. That is 1 meter cube is equal to 1000 liters. Therefore, Q is equal to 0.06 into 1000 liters per second. So this is about 60 liters per second. This is a simple problem regarding calculation of the loss of discharge of water through the pipe. Now we'll go to the next problem. In this problem, I'll read out the problem. Find the maximum power transmitted by a pipe to a power station of 3 kilometers long and 200 millimeter diameter. The pressure of water in the power station is 1500 kilopascal and Darcy's coefficient F is equal to 0.01. So the given data L is how much? It is 3 kilometers, that is 3 into 10 raised to 3 meters. Diameter of the pipe D is 200 millimeter divided by 1000, that is equal to 0.2 meter. The pressure 1500 kilopascal is equal to 1500 into 10 raised to 3 Newton per meter square, and Darcy's coefficient F is equal to 0.01. We know that the pressure head is given by, the pressure head at the power station is P divided by W. So P is 1500 into 10 raised to 3, and you know that the specific weight of water 9810, and this works out to be H is equal to 152.9 meter. And what he has asked? Maximum power to be transmitted. Maximum power for condition is HF is equal to H by 3. H is 152.9 divided by 3. Therefore, HF is equal to 50.9 meter. And we know that Q square is equal to FL Q square by 3D raised to 5, or you can use the previous equation only, that is Q is equal to under root of 3 HF D raised to 5 divided by F into L. So 3, HF 50.9, D 0.2 raised to 5, F 0.01 and L 3 into 10 raised to 3. If we calculate this, we will be getting Q is equal to 0.0403 meter cube per second. If you want to get this in liters per second, multiply by 1000 or keep as it is. But question has asked is maximum power. The power he has given is P is equal to W into Q into bracket capital H minus HF. W is 9810, Q is 0.0403, you already calculated, capital H 152.9 minus 50.9, and this works out to be 40.32 into 10 raised to 3 watt or 40.32 kilowatt, you can see. In this way you can calculate the maximum power by using the above equations. Now the problem number 3. This problem is the pressure at inlet of pipe is 400 kilopascal and pressure drop is 200 kilopascal. The pipeline is 1.5 kilometer long. If 100 kilowatt is to be transmitted over this pipeline, find the diameter of the pipe and efficiency of the transmission. Take Darcy's coefficient F is equal to 0.006. So the given data here is pressure P1 400 kilopascal, that is 400 into 10 raised to 3 Newton per meter square. Pressure drop means after that pressure drop P2 at the end of the pressure is 400 minus 200, that is equal to 200 kilopascal, that is 200 into 10 raised to 3 Newton per meter square. Length of the pipe 1.5 kilometer, that is equal to 1.5 into 10 raised to 3 meter. The power transmitted is 100 kilowatt, that is equal to 100 into 10 raised to 3 watt, and what you have to find is diameter of the pipe D and efficiency neta, and you have to take F is equal to 0.006. So we know that the power transmitted is given by P is equal to W into Q into bracket H minus HF. The pressure head at inlet is H is equal to P1 by W, that is 400 into 10 raised to 3 divided by 9810. This is to be about 40.77 meter. And head loss due to friction HF is equal to P2 by W, because he has given at the end of the pipe is how much? 200. 200 into 10 raised to 3 divided by 9810. This is to be 20.38 meter. Therefore P is equal to, substituting the value, we will be rearranging the term first. Q is equal to P divided by W into bracket H minus HF. So therefore P is 100, power he has given 100 into 10 raised to 3, W is 9810 into bracket capital H 40.77 minus HF 20.38, and discharge you can find 0.49 meter cube per second. By using this discharge, we can able to calculate the diameter. By using that equation, HF is equal to FL Q square divided by 3D raised to 5. This is another equation where D raised to 5 is equal to FL Q square divided by 3 into HF. Therefore, D is equal to the fifth root of FL Q square divided by 3HF. Substitute the value F 0.006, L 1.5 into 10 raised to 3, Q 0.49 square divided by 3, and HF is 20.38, and the diameter is to be found here. Fifth root you have to consider, and it is about 0.51 meter. This is the diameter. So another part is efficiency. We know that efficiency is equal to output by input. Output is difference in the head H minus HF. Input is the total head, that is H. Therefore 40.77 minus 20.38 divided by 40.77 into 100. It is to be about 50.01 percentage. This is the problem regarding that. Now we'll go to the another problem. So this is another kind of problem usually you can expect in the examination. So this problem deals with the things means how much power is to be, how much water is needed either for the city or for the hostel, some similar practical problems will be dealing with here. I will read out the problem. Water is supplied to a town of 4 lakh inhabitants. The reservoir is 6.4 kilometer away from the town and loss of head due to friction in pipeline is measured as 1.5 meter. Calculate the size of the supply main. If each inhabitant consumes 180 liters of water per day and half of daily supply is pumped in the cities, take the frictional factor for the pipeline as 0.03. So he has given number of habitants, how much? 4 lakh. And length of the pipe is how much? 6.4 kilometer, that is equal to 6.4 into 10 raised to 3 meter. HF, head loss he has given, is 1.5 meter. And per inhabitant, per candidate or per person consume 180 liters per day. That is, you convert liters into meter cube, it is 180 divided by 1000, that is 0.18 meter cube per day. Half of this, and how much time is required for that pumping? 8 hours he has mentioned here. So supply is pumped in 8 hours he has mentioned. Time is 8 hours and we want to calculate the size of the main. So quantity of water required is how much? 4 lakh people and each people is having 0.18 meter cube per day. Therefore, it is around 72,000 meter cube per day. But half of this is pumped by the pump. Half of this is supplied in 8 hours. Half of this means how much it is? 72,000 divided by 2 is 36,000 meter cube per day. This you want to calculate into discharge, you want to calculate per day, you convert into per second. How? Divide it by 8 into 60 into 60. 36,000 divided by 8 hours into 60 means minutes into 60 means a second. It is found to be Q is equal to 1.25 meter cube per second. And applying this equation, that is HF is equal to FL Q square divided by 3D raised to 5. You want to calculate the diameter of the main pipe. D raised to 5 is equal to FL Q square divided by 3HF, or D is equal to fifth root of, you can substitute the value F 0.06, L 6.4 into 10 raised to 3, Q 1.25 square divided by 3 into 1.5, and it is found to be D diameter of the main pipe is 2.316 meter. And we can also calculate HF is equal to FL Q square divided by 3D raised to 5. By using this equation also you can calculate here. It is found to be 0.158 meter. So this is the another problem which is important from the examination point of view. Next problem is a pipe of 60 meter long and 150 millimeter in diameter is connected to a water tank at the end and flows freely into the atmosphere at the outer end. One end is connected to the tank, other end is open. The height of the water level in the tank is 2.6 meter above the center of the pipe. The pipe is horizontal and HF is equal to 0.01. Determine the discharge through the pipe in liters per second if all the minor losses are to be considered. In the previous problem, we have neglected the minor losses. Here we have to consider the minor losses also. What he has given? Length of the pipe 60 meter, diameter of the pipe 150 millimeter, that is 0.15 meter, HF head loss due to friction 2.6 meter, and Darcy's coefficient F is equal to 0.01. You want to calculate the discharge. So considering all the losses, what we can write here is HF is equal to HF plus entry means loss at the entry, loss at the exit, and loss at the bend. It is given as HF is equal to 0.5 V square by 2G plus HF is 4FL V square by 2GD plus V square by 2G. Substituting, taking V square by 2G common, What we'll be getting is into bracket 0.5 plus 4 FL divided by D plus 1. And here he has given the value. Substituting all the values, you have to calculate only the velocity. The velocity you can find by substituting all the values. V is equal to 1.707 meter per second. And we know that Q is equal to A into V. So A is pi by 4 d square into V. So you want to calculate discharge. So pi by 4 into diameter is how much? 0.15 square into V, already we calculated 1.707. So the discharge is 0.0301 meter cube per second. But he asked the discharge in liters per second. Therefore multiply this by 1000. 0.0301 into 1000 is 30.1 liters per second. So this is another problem considering the minor losses also. ಹಾಗಿದ್ದು ನಾನು ಮಾತು ಭಾಳ